Hi folks, we're going to take a look at number 11 from page 451. So they give us these two lines, and in A they want us to find the k value that makes them parallel, and in B the k value that makes them perpendicular. Okay, so let's start with A. And here, in terms of the lines being parallel and perpendicular, we only have to work with their direction vectors. So the first thing I'm going to do is identify the direction vectors. So a direction vector for line 1 is going to be this one here that has the k value in it. So k plus 1, 3k plus 1, and k minus 3. And the direction vector in the second one is just going to be the coefficients of s, so -3, -10, and -5. Okay, so in order for two vectors to be parallel, we need them to be scalar multiples of each other. Okay, so there's going to be some a value, so I'll multiply again using a since k has already been used. So there's some a value such that am2 is equal to m1. So I just think it's easier to multiply that to this one here, which only has numerical values. Okay, so what does this mean? This means that if I have -3 times a, that's got to equal k plus 1. Okay, -10 times a has to be equal to 3k plus 1, the y component, and -5a has to be equal to k minus 3. Okay, but what we have here is we have three equations in two unknowns. You can only solve two equations in two unknowns at one time. So I'm just going to pick any two of these. Okay, so let me pick the first and the third since those look easier. Okay, so if I call this 1, 2, 3. Okay, what I'm going to do here is I'll subtract 1 minus 2 to eliminate the k. So if I have 1 minus 2, let's see what we get. We get -3 minus -5a, so -3 plus 5, that's 2a, is equal to k minus k is 0, and 1 minus -3 is 4. So I get that a has to be equal to 2, and I apologize, here is actually 1 minus 3 that we subtracted. Okay, and so now let's calculate the k value. So I'll take equation 1, so -3 times 2 is equal to k plus 1, so k is equal to -6 plus, minus 1 is -7. Okay, so this is the k value, okay, that will allow these two components to be scalar multiples of each other. Okay, now this is where there's an important step that you have to check, is that the component we didn't use also needs to be a scalar multiple of each other. So we actually need to check that this is indeed going to create that scenario. Okay, so if I take the a value, 2, and I multiply it by the y value here, so 2 times -10 gives me -20, and let's see what happens when I take this k value and put it into there. I have 3 times -7 plus 1, and that's also equal to -20. So that means that this works out. Okay, had this been 3k plus 2, this would not have worked out. It means that the k value that makes the first and third equal wasn't going to make the second one equal. So it's possible that there would have been no solution to this question here. Okay, so just to recap, I used the relationship between parallel vectors, that they have to be scalar multiples of each other, and from there I was able to use two of the equations to solve for k, but I needed to check that that value also worked for the equation that wasn't used. And because it did, we can say that k equals -7 will make these two vectors parallel to each other. Okay, so let's move on to B. So B needs these two vectors to be perpendicular to each other, because if the lines are perpendicular, so will the direction vectors. Okay, and here we're going to use the dot product, since the dot product of two perpendicular vectors is 0. So let's take, what do we have here? We have k plus 1, 3k plus 1, k minus 3, dotted with the other direction vector, -3, -10, -5, needs to be equal to 0. Okay, and here we have an equation to solve. So take the dot product, -3 times k plus 1 is going to be -3k minus 3. Here, -10 times this here is going to be -30k minus 10, and negative 5 times the last component here is going to be minus 5k plus 15, and that's going to be equal to 0. And this is actually an easier problem because I just end up with a linear equation. So here we have negative 3 minus 30, negative 33, minus 5 is negative 38. So I'll bring that to the other side of the equation, 38k. And so here negative 3, negative 13 plus 15 is 2. So k needs to be equal to 2 over 38. And of course that should be simplified to 1 over 19. Okay, and here we see that there is an answer and there's only one answer that works. Okay, so again, just to recap, we're using our properties that exist between parallel and perpendicular vectors. For vectors to be parallel, they need to be scalar multiples of each other, and for them to be perpendicular, their dot product needs to be equal to 0. Okay, that's it for this one.